Well, hello everyone. Let's turn on a little bit of light so we can see here. Oh, it's dark. There we go. KP the Math G here. We are talking about the 2013 free response question number 4. Now, this one, I have to admit, even if you know what you're doing, sometimes you get hung up a little bit, and you have to kind of focus and think about. And I'm thinking about question B, not question A. The other two questions are okay, I think, but I do want to at least do A and B today, and then I'll come back on the next one and do C and D, because B is going to take a little time to go over, and I would like to cover both C and D, the whole thing. Looking at the time, it's 8:25 this morning. So I just kind of want to keep up with the time, because my video camera there will only go about 32 minutes, and that's because it's old, I guess. Anyway, be that as it may, let's get on with the question. We're given that f at 8 is equal to 4. We want to find a local minimum. Keep in mind that this graph here that I've got in red is the graph of f prime. Alright, so not the graph of f, it's the graph of f prime. There are horizontal tangents at 1, and at 3, and at 5. Okay. We have areas given: 2, 6, 3, and 7. Bear in mind, if you wanted to, and the interval is from 0 to 8. So bear in mind, if you wanted to find total area, yes, or let's say maybe total anything, distance or whatever, you would simply add up these. Even the 3 that's below the x-axis is normally negative, but you would take the absolute value of each one. Okay. If you're talking about displacement, you'll still add up the ones above. These would be positive, but the 3 is the only one that would be negative. Just kind of as a review, which I know for the AP students, your test is coming up on May the 13th. So we are right here at it. As a matter of fact, today is the 8th, and so we're really close. And I'm going to try to do a few videos. I was out of town. I saw my daughter graduate, so I know that maybe some of y'all have already graduated. And if not, you're pretty close. And congratulations if you are a graduate this year. Okay. Anyway, and if you're taking a regular calculus course, you got a semester test coming up if you haven't taken it already. So wish all of you the best of luck. Okay, let's go on with the problem. We want to find a local minimum. All right, remember that a local minimum starts out from left to right, decreasing. The tangent line is the minimum has a slope of 0, max has a slope of 0, so these have slopes of 0 right here. These 3 right here. Alright? So we're looking at 1, 4, and 6, but we want to see this side is decreasing. The left side is decreasing, and you know it's decreasing. How do you know that you can look at a graph and say, hey, that is decreasing? And my cap just went way under the bed, and I'm not going to go under the bed to get it. Not right now, anyway. Okay, anyway. How do we know that something's decreasing? It's below the x-axis. Alright? Just because something is going down here, that doesn't mean it's decreasing. That's another thing we need to look at, which we'll look at in another video. but decreasing is below, increasing is above. So the only thing that's below the axis is between 4 and 6. If we look at 4, this is increasing and decreasing. So at x equals 4, that's a max here. This is a max, increasing, decreasing. We want decreasing and increasing. Alright, this is increasing and decreasing. So if it asks for a local max, this is it right here. Got a local max. This is neither a max nor a min really, because even though it does cross at 1, this is increasing and increasing. The signs don't change. So we don't have any kind of, we don't have that going here. Alright, but now this is decreasing at 6 and increasing above there. Alright, there it is right there. So this would be the local minimum. Local minimum at x equals 6 because signs change. Alright, from negative to positive at x equals 6. And that's all you need to do with A. That's it. Okay. B part. Let's look at that. Get a different color. Now this is the part that I really want to discuss, because it can be difficult. I have to admit, it can be a little bit challenging, confusing, difficult. You got to be aware that f at 8 is 4 right here. Looking at right there. Okay, so alright. By the way, if you're looking for a local minimum or a local maximum, you're not even looking at the endpoints. The extreme value theorem is only for absolute maximums and minimums, not for local maximum minimum. Okay, so we do have a minimum at x equals 6. Alright, so just kind of keep that in mind, because that brings us into B part. It says determine the absolute minimum value of f. Alright, now we're talking about the absolute minimum value of f, not f prime, on the interval from, I won't always say t every time. Alright, this is the interval right here. So we are looking at this. Now remember, this is the graph of f prime. Now, there's a rule. Remember that there's a fundamental theorem of the calculus that says that the antiderivative of f prime, remember what that is, let's say from a to b, that's equal to f at a minus f at b. Okay, if we have that, that's the fundamental theorem of the calculus. Now this is how we get to f. We are looking, well, in the particular case, we're looking for a minimum value of f. Well, we have to get to f by integrating f prime. Okay, that's the only way we're going to get to f. Okay. Alright, so let's see what we have to find. We need to find three things. F at 0. We need to find f at 0. Now we know that there is a local minimum, f at 6. And we also need to look at f at 8. But we're given that f at 8 is 4. So we already know what F at 8 is. F at 8 is 4. Okay? We just need to find F at 0 and F at 6. It's going to involve F at 8 on both of these. So let's examine how we do this. Okay? Alright, I'm thinking about, now let's think about F at 0. Okay? You have to think about working your way backwards. We're not moving forward, we're moving backwards to 0. So really what we're looking at, and I had to kind of study this and study it several times. You're working your way backwards, okay, to 0. So really you're looking at the, if we're starting at 8 and going to 0, F prime at x dx. Okay, that's really what we're doing on this one here. We're looking backwards. We want to go back to 0. But remember that rule, there is a rule that says, and look at this, just kind of think about this, and I'm going to try to keep it on the front of the board. Technically, this is F at 0 minus F at 8. I mean, isn't it? I mean, that's what this actually means. That, again, from A to B, F prime at x dx is F at equals F at A, B rather, B minus F at A. And that's what that means. And you might encounter, at least you're going to, you know, I'm not guaranteeing you on that test you're going to have a problem like this, but should you have it and you got to take the, you're integrating F prime or G prime, then you just got to know it's F of something minus F of something else. F the upper limit minus F of the lower limit. And that's what this means here. Well, now I have to find F at 0. So since this is equal to this, then I simply want to solve for that. So let me turn over the board. I'm just not going to have enough room to do that. So I'm saying that we're looking at going backwards. I know this sounds really confusing, but you're looking at F at 0. Alright, so this is going to be F prime at x dx. This is equal to F at 0 minus F at 8. So if I'm looking for F at 0, which is one of the endpoints, I'm going to add this to both sides. Okay. Plus F at 8. So now this is going to be, if I look at it this way, it's F at 8 plus integrating from 8 to 0, F at x dx. To know that you got to work backwards, you're working backwards because you want to get back to F at 0. That's about the best explanation I can give you on that one. You got to get back to it. Well, now there's a rule that says I really don't want the bigger number to be on the bottom, so you just simply negate that, and now you are going, and if you don't remember anything else, just kind of remember that, and then just flip it over and put a minus sign instead of a plus, because you're negating it. Now we got to flip over because we know F at 8 is 4. Now let's put down everything from 0 to 8. I think the first one was a 2. The second one is 6. The third one is 3, but 3 is below the x-axis. And then the last one was 7. Let's look at that. 2, 6, negative 3, and 7. There it is. I've got this thing. 2, 6, negative 3 and 7. Negative because this is below the x-axis. All of these are positives, but now remember, we're negating this because we are working backwards. So this is equal to, and we already negated it really because we just flipped the sign over. 4 minus, okay, now 2 plus 6 is 8, 8 minus 3 is 5, 5 plus 7 is 12, so 4 minus, we're negating here, so 4 minus 12 is negative 8. So we know then, let's put over here in the corner, F at 0 is equal to negative 8. We already know that F at 8 is given to be 4. Alright, so whatever it's given to be, just take it as it is. Alright, now, let's erase all of this, because now we have found F at 0. Alright, we already know what F at 8 is. We are looking at that local minimum that we just found from question 1. We're looking for the absolute minimum, so remember, that's why we had to pick the endpoints according to EVT, extreme value theorem. You're looking at endpoints, and you're also looking at the local minimum. So now we need F at 6. Okay, so let me erase this. Okay. Alright, now, well, I need F at 6. Again, it's going to be from 8 to 6. F prime, if it's F prime, that's the only way I can change F prime to F. I've got to I've got to integrate, and again, I'm working backwards, okay? Alright, so doing that, I know that this is F at 6, F at 6 minus F at 8. And like I say, I understand it if I'm looking for F at 6, I'm simply going to solve for F at 6. And again, I know this looks confusing, doesn't it? But you got to remember, you are working backwards, okay? Alright, so plus F at 8. Alright. Alright, and now we do just have F at 6 by itself. That's equal to F at 8 plus, actually from, 8 to 6. 8 to 6, F prime at X, dx. I tell you what, students, if you really would like to just say, hey, this is 4, just go ahead and negate it and know that you are going from 6 to 8. That's really, you're flipping this over. Just go ahead and do that. And I almost started to teach you that way, but I see too many. I watch videos too, by the way, sometimes, and I need a refresher. I mean, being out of it for a few years, it kind of, I'd like to see what other professionals are saying, and they really, and I understand this, and then. So I do know that you just have to, you flip it over. You want to do that. You change this sign from plus to minus here. So now it's got to be 4 minus. And keep this in parentheses because you're minusing the whole thing. Now you're simply wanting to go from 6 to 8, which is really one number, I think. From 6 to 8, it is 7. So really we're negating 7. Alright, it's not so big as it was in the last problem. So 4 minus 7 is negative 3. So now F at 6 is equal to negative 3. Now, usually in my observation that I have found that usually an endpoint doesn't get, sometimes it doesn't, but sometimes it does. And this is a case where one of the endpoints gets the, and then remember, we're looking for an absolute min. Well, this would be your absolute min. This is the smallest number, okay? So f at 0 equals -8 is the absolute min on the interval. And that's what they want to see. They want to see the evidence is in the work that you're doing here. Do you necessarily have to do this? No, you can still go from 6 to 8, but you just got to subtract it off. Okay. But you have to include f at 8 in this. Okay. It's kind of like an initial condition. That's really what they're kind of wanting you to see out of this. Okay. Alright, so that's what you had to do with C part. Actually, that was B part rather. Okay. Alright, so that's basically what I wanted to show you. Okay. Maybe we have time to do one more. So let's see. I like to. Let's see. Okay, let's see. How much time have we looked at so far? It was 8:25. Whoa, we're getting close. So, yeah, I better shut this off. And really and truly, when you think about it, C and D probably, no, they don't really go together, but they are. It's kind of a different concept than what we're talking about here. And I really wanted to get you familiar with this. And again, you know, anytime, you just got to remember, anytime you're dealing with, you want, if you want, alright, if you want f at some letter, okay, maybe we want f at a, then, well, alright, we want to do that. Alright, so, and we got f prime at x, then it is f at b minus f at a. And of course, in our case, we had it flipped backwards, didn't we? So in this case, it would be f at a minus f at b. Alright. I always like to think too, I mean, if I want f at 0, I don't want f at 8, I already know what f at 8 is. I'm moving back to 0. I'm going backwards to 0. I'm going backwards to 6. Okay. Alright. If they had to deal with the absolute maximum, you can't use 6, you'd have to use 4. So if they had to ask for the absolute maximum, you would still use the endpoints, 0 and 8. We know that f at 8 was 4 anyway. Then you have to look for f at 4. And still do the same thing that you did a while ago. Alright. Absolute max, 0, 4, and 8. Okay. Absolute min, 0, 6, and 8. I hope that's helped you. Alright. This is KP the Math G. We're going to go ahead and sign off because I don't know how much more time we have. And I would like to keep this separate anyway. 2 other good questions, and we'll look at those the next time. This makes my 130th video, so please, if you will, if you haven't subscribed, go ahead and subscribe. If you want to make a comment, would like to do that, please do so. I appreciate your comments. And then, of course, that like button. See, I'm already smiling. Yeah, I like those. Anyway, regardless of whether you give me a like or not, or make a comment or subscribe, I'm just hoping that this helps you. As I always say, it's for your glory, not for mine. Okay. I'm not here to get a whole bunch of credit. I just want to help you understand what this here is all about. Okay, that sums it up for me this morning. This is KP the Math G signing off. Have a great, great day.